Good afternoon, ladies and gentlemen. Welcome back to the second session for the day on key trends in big data, cloud, and data analytics. With immense pleasure, I would like to introduce the speaker for the session, Mr. Thomas Sebastian, Solution Consultant and Architect, TCS Cochin. Mr. Thomas is a certified big data professional with 15 years of IT industry experience. He has expertise in enterprise solution integration and re-engineering for the data and analytics projects using big data and cloud technologies. He has also proven his expertise as Cloudera certified HBase specialist, Databricks certified Spark developer, and Cloudera certified Hadoop developer. On behalf of all of you present over here, I welcome Mr. Thomas Sebastian to the session. Over to you, sir.
Yeah. Thank you. Thank you for the introduction. I hope we can start the session now, right?
Yes, sir.
Okay. All right. So good afternoon, all of you. Myself, Thomas Sebastian from Tata Consultancy Services Limited, based out of here in Kochi, working as a solution consultant and architect. So today, we are going to speak about or discuss about the key trends in big data, cloud, and data analytics. So we have a 1 hour session. So what I'm trying to do is I'll try to wrap up the contents in the first 50 minutes, so that at least last 5 to 10 minutes we could plan for the Q&A. With that, let me start the session. So today, what I would like to cover from an agenda point of view, I'll start with the evolution of big data analytics, followed by the key trends, especially from a platform architecture and application point of view. You might see many of the technology representations as a part of many of the trends and the applications. Some are indicative, some have been taken as a reference from the public space. So starting with the evolution part. So big data, as you all know, it has been so relevant these days, right? When you say big data, it is not just, you cannot say that it is a standalone setup. Cloud and analytics is also coming in combination with the big data. So that is how big data has been evolving. And that has been a most fundamental driving factor for most of the enterprises, especially to grow in a world of becoming organizations into a data-driven method, whereby which your organization is fundamentally based on many of the data-driven applications. So that is the way organizations have thought through and started replatforming themselves in the modern times. So as you can see, the data can be of multiple varieties, um, be it a manufacturing industry, or be it an IoT or a Internet of Things or sensors, or be it a retail. The data has been generating from multiple domains and even multiple industries, right? And initially, when you say about big data, it was just three V's. The three characteristics was volume, velocity, and variety. And now it has grown into the five V's, where veracity and value is also getting added. The veracity is specifically the uncertainty of the data that is coming into picture, and the value is about bringing in the value out of this data. So obviously, the data that has been generated out of these industries are of immense volume, and it becomes important to tackle this big volume in combination with the different technology stacks that is available. Moving on to the next slide, these are just some indicative numbers of the big data that is getting generated today or maybe a couple of years before. The idea is that a lot of digital disruption has been happening during these times, whereby which the data is also getting generated as a part of the disruption, right? As I mentioned, as a part of companies becoming data driven, whereas earlier companies were more specific to the data centric kind of culture. So I'll explain a bit more in the coming slides about data driven versus data centric. And another important aspect is with respect to the cloud, right? So we saw the big data, how the big data is getting evolved. The impact of cloud is also tremendous. These are some of the predictions that is happening. As you can see from the industry leaders and industry experts, that 70 to 80% of the IT spend even can go into the cloud specific investments, that can happen. So it is going to be cloud is going to bring in a lot of impact, and it has already started bringing in that kind of impact. Again, it is expected to be like 80 billion IoT devices to be, being online by 2025. And it's like 180 zettabyte of data that can get generated, right? So that is a way cloud is having a lot of impact. And why cloud is making an impact, especially cost optimization. When it comes to cost optimization, it is the capex versus opex cost. In a traditional way, when you have a servers or a setup planned out of an on-premise setup, you need to have a upfront cost that is involved, where you have to purchase some servers for the databases or your environment. But whereas in cloud, we get a lot of flexibility, and also OpEx cost optimizations, especially on the operational aspects. And then obviously it helps an organization to go quickly into the market to derive insights. Another important aspect is the different computing paradigms that is getting coming up as a part of the cloud platforms, where the maintenance is of very, very less in nature. And as you can see, hybrid, private, or public cloud, all of these cloud platforms are getting prominent, and in combination with the big data, it is making a tremendous impact. And then now coming to the application side, what has been an application from a big data point of view, right? Some of the applications, we heard that some large search engine process 24 petabytes a day, probably 10 years before. These are some numbers 10 years before. A movie like Avatar would take like 1 petabyte of local storage for including the 3D effects. So this is the way the data has been evolving, and the applications around the data has also been evolving. Be it be it an IoT specific application where sensors are deployed across multiple industries and data is getting extracted out of it, be it the real time insights getting generated out of the applications, be it self-service analytics, business intelligence, AI and machine learning, deep learning and cognitive analytics. So all of these things are getting evolved as a part of the application evolution. So far we saw from an evolution point of view how the big data has been evolving, how the big data in combination with the cloud is creating an impact, and how applications are also evolving, right? So from a platform perspective, especially when it comes to big data, distributed computing is going to be a very important aspect. And grid computing has been one of the prominent aspect. Earlier we had high performance computing clusters, HPC, and then Hadoop, Spark, and Sparks of the world came into picture. And obviously we have cloud compute with the hybrid cloud. Even HPC is also holding good for certain industries. I'll explain in the coming slides. So these are the way in which platform is also getting evolved when it comes to in combination with the big data. So now let us get into some of the key trends. So when we say key trends, it would be like I'm trying to capture that kind of trends from a compute perspective, storage perspective, governance, business models, applications, analytics, etc. And that is where we are trying to delve a little bit deeper into in the coming slides. So let me start with the storage trends. So in the storage trends, there is something like, let us start with the some of the storage architecture trends. So you might have already heard about the data lake as a term, right? So data lake would be something where you actually pump the data from multiple source systems, including on-premise or even a real-time systems. And ultimately you create a lake of data. And once you create the data lake, you should leverage that particular data for your subsequent analytical purposes. So for example, machine learning or advanced analytical models or deep learning, etc., would be performed on top of the data lake. So that is where customers or enterprises were thinking about, okay, we should be, okay, we have been data centric where we go with the predefined data models, but now it has to be a scenario where I have to go data driven, you know, along with taking the positives from the data centric nature. So when it comes to data driven, enterprises try to bring in the the agility of the data lake, along with a lot of exploratory analytics also getting into picture, where people can bring in or generate insights out of that your systems. So that is how the key storage architecture trends has been. And enterprises try to take the best out of data-centric and data-driven culture in terms of a storage architecture. Now, some of the key storage technologies, I'm just giving a representation. It is not just limited to this. Still, NoSQL databases has been another key trend in the industry. So as you might already know, there are different kinds of NoSQL databases. Some of them could be columnar in nature. Some of them would be key value type NoSQL databases. But each of these databases being specifically addressing the scalability needs of an enterprise. And whenever you have a specific access need or an access pattern that is defined upfront, you can leverage the NoSQL solutions. So it can be HBases or Cassandras of the world. Those are some prominent NoSQL databases available. And obviously, you might already know about the CAP theorem, right? So where consistency and availability are getting tuned along with the partition tolerance. So multiple NoSQL databases comes in that flavor. The other aspect is the object storage. So traditionally, we have been storing the data on disk-based systems. So now object storage is bringing in a lot of flavor with a lot of cost efficiency. where you can have the data stored in a much cheaper way. If it is at an on-premise kind of system, it will be safe for uh, you know those kind of object stores. Whereas in cloud, it can be Amazon S3 or Microsoft Azure Blob. Those are the kind of object storages that is being leveraged. So specifically, kind of a file-based storages with a lot of scalability and a lot of cost efficiency. So that is another trend that is being seen from a storage point of view. Then coming to the cloud data warehouses. So we all have been seeing the data warehouse in the on-premises. You might be knowing like Oracle is there, Teradata is there, Netezas are there. So now the trend is like, people wanted to leverage the cloud. Remember the impact of cloud I mentioned in the beginning. All those positives and the advantages that is coming out of cloud, especially in terms of cost and the flexibility and the time to market, how a warehouse can be kept on the cloud. So that is where a lot of technologies like Google BigQuery, SQL Data Warehouse, Amazon Redshift, these are coming into picture. And Snowflake is also another kind of SQL Data Warehouse. So a lot of enterprises are moving in this way as well, where you want a data warehouse on cloud. So that is just a glimpse about the storage trends. So let me just move on to the compute trends. So when it comes to the compute trends, we know that there are different kinds of compute paradigms or services offered by the cloud platform. So now it is like IaaS, infrastructure as a service, or a platform as a service, or a function as a service, or software as a service. And there is one more, which is container as a service, which I'll explain a little bit later. So why these trends are getting prominent now? An enterprise would like to go predominantly with a PaaS or a FaaS or SaaS. The key advantage of the platform as a service or a SaaS, software as a service, is that they can reduce the impact of management or the maintenance of their on-premise system, because these things are getting managed by the cloud, and customer just needs to focus on their applications or application logic. So that is the way customers are moving on. And then function as a service is also getting predominant, especially when you have a lot of small compute aspects you have to run. So for example, I wanted to process a 1 MB worth processing logic. Do I need a big machine with 10 GB RAM and all? No, it's not needed. So I can simply leverage a function as a service where I can simply use a small compute unit for executing that function. So this fundamentally describes the difference. Infrastructure as a service, as you all might be already knowing, you are simply installing your required hardwares and softwares on a cloud platform. Whereas in platform as a service, you're reducing that. So in this particular slide, it will some of the things are getting clarified. So for example, IaaS or infrastructure as a service, the service provider is, as you can see this color, so this gray color, the service provider is actually managing the infrastructure, whereas rest of this functionalities has to be managed by a customer. And whereas it goes to the PaaS or FaaS or SaaS, you can see all of this management efforts are going into the cloud service provider. Whereas an end user, it just needs to focus on their application logic. So that is how the compute trends are going on. And you can very well see container as a service, the entire thing being deployed into containers is the container as a service. Now coming to the compute infrastructure trends, right? So we saw the service level trends. There are certain kind of trends with respect to the hardwares as well. So traditionally we have been leveraging CPU or a GPU, and now FPGA and ASIC, etc., are being you know introduced in the market and being leveraged. And the reason being, as again, you have the huge scale of the data. Your data is moved from structured to the unstructured, where a lot of images, videos, etc. is getting into picture. A lot of analytics has to be done on top of that. So you need to have the necessary hardware for doing that, right? So that is how GPUs and FPGAs are coming into picture. So the advantage of FPGA, for example, would be that the latency is like 1 microsecond latency, whereas a CPU it can be like 50 microseconds. So that is a way, especially when you have huge volume of terabyte and petabytes of data volume, you wanted to process. That is where these hardwares are also bringing in some effect. So we can very well see a lot of AML driven use cases are being deployed and built with the help of this kind of hardware setups. And even cloud vendors are also providing services. Say, for example, AWS provides FPGA services. Microsoft offshore already leverage FPGA for their data centers. So that way, a lot of things are getting coming. And also, as a part of this, hardwares are getting evolved. Energy efficiency is also one of the important aspect. That is getting a positive and also reduces the cost per unit. Another aspect is cloud bursting. So we know that traditionally applications have been running on private cloud or even on-premise systems, right? But how about migrating entire thing into cloud instead of migrating entire thing into a public cloud? Especially you might have scenarios where a bank customer may not feel comfortable to migrate entire setup into cloud, because cloud again, it is another data center owned by a cloud vendor, right? Like a Microsoft Azure or Google or AWS. But in this kind of scenarios for cloud bursting, how about bursting my compute needs along into the public cloud? So that is where cloud bursting comes into picture. And Google Cloud, Anthos, Azure Stack, AWS Outpost are some of the examples whereby which they help for extending from the on-premise systems into the cloud. So this is again another compute trend that I would like to touch upon. So far we saw the cloud compute trends, especially from service models which was given by offered by the cloud vendors, IaaS, PaaS, and SaaS, and then the different compute from a hardware point of view. What are the key compute options that is getting leveraged? And then we also saw the cloud bursting scenarios, right? Where hybrid clouds like Anthos are being leveraged. Now coming into the governance trends, it is very important that say for the example, earlier you saw the data lake, right? So data lake is like where you pump the data from multiple source systems into a single kind of a storage. And it will not just create some value out of that, right? You remember the fifth V out of a big data, right? So in order to generate the value, you need to understand the data. You need to have a proper cataloging done on the data. You should have a good harmonization of the data uh, performed on top of the data. So that is where data ops is coming into picture. So data ops has been a tremendous trend in terms of a governance that has been coming here. Especially you have from a data lifecycle point of view, you will have data onboarding into a platform. Then you'll have data curation happening where you'll apply your transformation and the processing. And then you will have the metadata management where you will define the catalog. You'll also define the lineage between the data. Then data governance, especially with respect to the security, data encryption and data authentication, authorization, etc., has to be performed, and self-service, making the entire system available as a self-service, right? So those things are very important as a part of your data lake kind of a setup. And there is a huge possibility of building automation into this, and that is where data ops comes into picture, data operations. And it can benefit a lot, and it can actually improve the productivity in a much better fashion. So now coming to the another aspect of the governance, that is infrastructure as a code. So we know that when you want to execute something, you need to have an infrastructure. And when it comes to the cloud, it might be that you just simply say that I just need this particular infrastructure, and I wanted to spin up the infrastructure in just a, a click of a couple of buttons, right? So that is where infrastructure as a code that is coming into picture. So typically what we do, we plan an infrastructure, we do some kind of a developmental activity, create it, verify it, package it. And then what you do, you actually you have to have a release mechanism, configure it and monitor it. This, you might already know, this is the DevOps, right? Developmental activities and operational activities. That is where infrastructure as a code bringing in a lot of value, where you can build a lot of automation in terms of DevOps. So if you just take some example, Azure ARM template or AWS cloud formation, etc., are some of the examples where they provide an option for maintaining your infrastructure as a code, right? And even this is just an example. Say, for example, some of the people in IT industry, they start developing something, they write some program, and that program you are uh, maintaining your continuous integration process with the source code repository, and there can be an infrastructure code also which is coming into picture along with your application code, which will help you for building the entire pipeline. And then just on a click of a button, you build the code, deploy the code, spin up the infrastructure as well, because you already have your infrastructure deployed and developed as a code. So this is another trend customers are looking for in terms of the governance trends. And then there can be multiple technologies as well, right? So Terraform being one of the important aspect where you can configure an infrastructure as a code. And then you have some deployment configuration management tools like Chef, Ansible, etc. Are some of the tools that is being leveraged in this kind of scenarios. Now, the other aspect with respect to governance trends is the containerization. So this is getting a lot of prominence in terms of governance and deployment. So we know that we have multiple cloud, we have on-premise system, we have cloud. How can you make your system platform agnostic? If you want to make it platform agnostic, you should be able to deploy it in a similar platform everywhere, right? In order to do that, Kubernetes is something that is providing this kind of an option. So Kubernetes helps you to build containers with the help of Docker images, and these containers can be deployed across the servers or the databases or the environment, so that you can have a distributed way of handling it. So that is where your containerization coming into picture. So once you build such kind of an application, you just need to configure something called a YAML file. You define your containers, and this thing can be deployed across platforms. Be say suppose you are developing it in on-premise, you just need to simply click and deploy it in a Azure-based system or an AWS-based system. So Kubernetes-based system is getting a lot of traction in this particular aspect. So far we saw from a governance point of view, the data ops, the different components in the data ops, um, the infrastructure as a code setup. How do you, along with application code, when you have the DevOps happening, how do you manage the infrastructure also as a code, and then the containerization aspects. So these are the key trends that we see at the moment with respect to the governance trends. Now let us move on to the analytics trends. So in the analytics trends, there are different kinds of analytics, right? So BA analytics, you might already be familiar. Business intelligence aspects. This has been the fundamental analytical modules that customers or enterprises would be looking for. Say, for example, the tools like Tableau or MicroStrategy. So they build some specific reports that is required for an organization. So as you know, decision support systems are the uh, the basic building blocks for a enterprise. Say, for example, a retail like a Walmart or a retail like H&M would be looking for how their sales are performing, or um, a retail like GeoMart would be looking for how their profits are growing, right? So they wanted to understand that. So there should be some kind of an analysis to be done, and they typically leverage the BI-based systems as a part of the business intelligence. But typically, it has been building dashboards and reports out of the BI-based system. But now you can see a lot of things coming into picture, which is getting integrated into the BI-based system. Say, for example, NLP and NLG, right? Where natural language processing also getting integrated along with the BA-based system. Some of the examples are like Tableau with the bespoke architecture. Then real-time visualization. So far we have been thinking about the canned reports and all. How about streaming a data and showing it in a, say for example, Power BI is one of the solution, right? Then cognitive analytics. So there are pre-built analytics that is already been available with many of the cloud vendors. So how about integrating that and also leveraging along with the BA-based analytics? Geospatial insights. So geospatial insights is specifically on the geographical level mapping and analysis, where we can visualize many of those aspects, especially when you have sensor data deployed across the globe, how that sensor is generating the data and it's getting collected over the areas, right? Time series visualization. So you know that the data which is getting generated out of machines, etc., are time bound, right? So those kind of data would have to be visualized in a specific fashion. uh, it may not be a traditional way of representing in a BI, right? And obviously consolidation, modernization, and cloudification. So these are the key trends that we see from a BI analytics point of view. And then coming to some of the advanced analytical trends, right? So we know that there is R-based packages, etc., which we can leverage and execute some of the analytical algorithms, or some of the analytical libraries. We can execute that. But when it comes to huge data volume, is that enough? It may not be, right? Say, for example, you're building an application for a auto manufacturer. They wanted to build an autonomous driving car. So one of the key aspect is that during the build, they have to consume the videos of a car driving scenario, and then you have to convert that particular video into images, and the images you might need to identify an object. Say, for example, there is a stop signal in the road, so the car has to automatically stop over there, right? So in order to do that, there has to be some object identification. But these kind of executions, how will you do that? So in order to do that executions, you should have some kind of a distributed computing algorithm. So a traditional way of executing in a single threaded may not fly, because you have a huge terabytes and petabytes of volume, and you cannot simply run on a single threaded way. So that is why a lot of technologies come into picture, like Spark MLlib, PySpark, PyTorch, then TensorFlow. So distributedness of this algorithm is very important. So that is why a lot of analysis happening with that in that way. Then comes the sandboxing aspect. So typically from an analytical point of view, we should have as a data scientist who is working in an organization should have the necessary softwares and the necessary data as and when required. So he shouldn't wait for an IT department to generate the data for him. So he should have that sandboxing to be done as and when needed. Along with that, he also should have some data wrangling capacity. So it's just an example. Say, for example, Trifactor is one of the examples where you can do some data wrangling, where you can discover the data, clean the data, enrich the data, validate the data, and then publish the data as and when required. So those are some of the analytical trends. And another aspect is the ML ops. So we know that in a typical developmental application scenario, you have DevOps, where you're handling the CI/CD, right? Continuous integration and continuous deployment. How about in ML ops? How are you going to handle that? So ML ops is not just the continuous delivery or automation pipeline. The automation of the entire continuous integration, continuous delivery, continuous training of the machine learning models. So this covers all of the systems as a part of the MLOps. So you may feel that in a typical data developmental system, you have the unit testing, integration testing, continuous delivery, all those things happening. How MLOps is differing, right? So say for example, continuous integration. It is not just testing and validating. When it comes to machine learning, you should have a testing and validation of some of the models and some of the data schemas. And when it comes to continuous deployment, and when it comes to machine learning, you should have the mechanism to um, automatically deploy, ML as a service. Model prediction services you should be able to deploy. And then continuous training mechanism, right? You should be automatically retraining and serving the models. So though all of those things are very important when it comes to the ML ops. And another important aspect is the model management. So this is just an example. Say Google is providing like Auto ML, right? So you have a machine learning model, you are building a model, and you should have a mechanism whereby which you should be able to deploy it, manage it, maintain it, right? So those are some services also being offered. So that is why ML ops is also getting a lot of traction. And at the end of the day, you should be able to deploy this ML as a service, right? Should be able to be consumable with some REST API integrations. So these are some examples that I'm quoting here from an MLOps point of view. And another important aspect is the explainable AI. So this is one area which is getting matured, and a lot of innovations and investments are happening in this particular area. This is fundamentally required, as you know, right? When it comes to advanced analytics or artificial intelligence, people have to depend on or trust on the kind of models that is available in the market. So for example, you're using a model to predict an image, whether that particular image is equivalent to a cat or a dog. I'm just giving an example. So those kind of prediction mechanisms, we are actually depending on that particular library. But how exactly this prediction happens? Why that kind of prediction happens? So that is where the explainable AI comes into picture. So it actually brings in that kind of information for an end user, especially the end user is going to be an auditor. So in this kind of scenarios where people are actually having, end users where audit is getting a lot of traction, right? So say for example, in banking, you're saying that I've generated a model whereby which I'm trying to, understand the model, or I'm trying to understand the frauds in the system. So an auditor should be able to understand how we are defining that and why it is saying that you're having an accuracy of say 80% or 90%, right? So that is where explainable AI is coming into picture, and traceability along with that. Why this kind of a model is presenting something like that. So that is very important. So traceability and auditability. So these are the key aspects that when it comes to analytics point of view. Um, Say, for example, we covered the business intelligence analytics specific trends, then the advanced analytical trends in terms of the distributedness, and then the ML ops, which is getting a lot of traction. Then we also saw the need of an explainable AI, right, along with the model management. So now let us get into some of the business models, right? So the business models, these are some of the examples. Say, for example, right now, ultimately, customer looks for data monetization. Say, for example, a retail customer would capture the point of sale kind of transaction information from many of the customers. They would try to understand how a customer purchase behavior is there. You know, a customer purchase behavior on winter might be different from a summer season. Um, apart from that, this particular research customers will also help to understand or will also help to make certain kind of decisions. Say, for example, what would be the best in class product that can be launched, say in the month of December or maybe in the month of March. So there are many factors which is actually affecting this kind of decisions. So that is where data is the prominent aspect of the, and data is actually being leveraged for the monetization aspect. And many of the scenarios, many of these retail companies and all offer the data as a service, whereby which an end analyst or an end researcher can use that particular data and then analyze it and bring some insights out of it. Another important aspect is the data democratization. So this is where another business model where, say, now we understand that as a part of the machine learning and AML in the driven world, there is a lot of data scientist role is coming into picture. And it's also important that you should take the capability and the talent of the people who is not that much familiar into that particular areas, because a lot of people can contribute in that area. So that is why data democratization is coming into picture, where data should be made available for any of the people in this particular organization who may not be having that kind of a what do you say background, but they can leverage the data democratization aspects, and then they can actually uh, generate the insights and help the organization grow in much better fashion. So that is why the data democratization comes into picture. So all we have to do is that we should be enabling that particular person with the required tools. Then the other aspect comes into picture, which is the self-service analytics. This is a big area that people are actually looking at. So especially as a part of, in combination with the data democratization, self-service analytics is a form of business intelligence in which many of that business professionals can be, can leverage a self-service tool and bring in the data of their own, generate the insights out of it. What happens in a typical project, right? So people actually wait for, or a business actually wait for an IT driven canned report, whereas in self-service analytics, a lot of flexibility is given to the business people itself, who can actually extract the data, analyze the data in a much faster fashion, and in a much speedier fashion. So that is how the self-service analytics is getting into prominence in much in these days. Another aspect, data ops as a service, which I already explained, data ops as a service, and this data ops as a service is another important aspect that is coming into picture. So that's how it is going on. Yeah, just give me a minute. Yeah. So so far we covered the different aspects with respect to the business models as well, the data monetization, democratization, data as a service. So now let us take a look at the some of the architecture patterns as well, right? So these are also some trends that is getting generated as a part of the systems. So we saw like data lake being fundamentally, building the data, pumping the data into one single repository and making it available, right? And then you have lake house is being one of the pattern, where data lake and a data warehouse being combined together. So data lake would be your fundamental landing zone. Your raw data will be there, and then you build a data warehouse on top of the data lake. When you say on top, it's an extension to data lake, where your fundamental structured data kind of analysis would be leveraged using data warehouse. So you remember the other technologies like the BigQuery or the Snowflake or Azure SQL data warehouse. So this kind of cloud data warehouses bring in a lot of value along with this data lake as a lake house architecture. So these are some representation of the technologies like Amazon Redshift, um, then Microsoft Azure SQL data warehouses, then BigQuery, Snowflake, etc. Then another thing is with respect to the architecture itself, right? So you might be familiar with the Lambda architecture that we typically do with the both batch-based executions and also the real-time based executions happening on the Lambda architecture. But whereas in Kappa architecture, we leverage a single architecture for both streaming and batch kind of executions. So that is a fundamental difference. So typically Kappa architecture would be like a Kafka based kind of architecture where you have the PubSub mechanism being handled by Kafka. You can even have streaming data and also some level of batch data you can capture over there. So the main difference would be that the Kappa architecture, every data is actually treated as a stream, as something like a stream. So your real-time data, batch data, everything is happening through the Kappa architecture. So that is another trend that we can see, especially say, for example, a telecom domain, right? In telecom domain, you can have data coming from multiple protocols. The protocol can be a telecom device, or it can be the mobile devices. It can be a syslog, it can be FTP, or it can be uh, JetFlow, Enflow. So different kinds of protocols are there. So these kinds of data definitely you can actually leverage, are all of streaming nature. We can leverage Kappa kind of architecture. But at the same time, Lambda has got its own advantages, especially when you have to have a huge batch data getting ingested. Very expensive operations has to be performed. Lambda architecture has to be leveraged. So it is not that Lambda should always be replaced with Kappa. But there are advantages and disadvantages which we typically leverage. These are some cloud reference architecture. As you typically see, you will have data onboarding and then data analytics, data processing, analytics, consumption, governance. So these are the fundamental building blocks if you look at any kind of cloud architecture. It can be AWS, it can be Azure, it can be BigQuery. So these are different reference architecture, and these gets evolved over time. So I would suggest if you're interested to take a look at the specific cloud sites for each of the cloud vendors to understand this reference architecture. So far we actually covered the different kinds of trends: storage, compute, analytics, business models, governance. So now let me also quickly give a glimpse about some of the key applications as well. How this has been growing out, and then probably I'll pause for a while and take questions. So some of the key applications are like, say for example, investment banking, right? So in investment banking, a bank try to understand the party-to-party relationship between the customers. So the customers can be of employee relationship, it can be of a family relationship. So advantage is that they can cross-sell the products which between the similarly affiliated customers. So banks try to do analysis in that way. Banks, certain retail banks customers, retail banking organization, they will try to understand how their credit card usages are going on. How's the loan reimbursement processing is happening. Can we have that loan processing made much faster? Certain banks are like they have like call centers and unnecessarily a lot of calls that they are making, unnecessarily a lot of follow-ups that they are doing. So many of those things can be optimized. So many of these analytics are being performed by bank. And when it comes to telecom, what they try to do is like, first of all, from the network itself, how the network is performing. So they wanted to understand how the network alarms are getting generated, how it can be, utilized for, many of the optimization of their work, their maintenance work, right? Can they have a predictive maintenance? They can predict some sort of a failure of, say, for example, one particular network device, and can they plan accordingly? So that is where the telecom comes into picture. Manufacturing, as I mentioned, connected car and autonomous driving ecosystem, right? So the example I already mentioned, where people try to record the, obviously an autonomous car before launching, they have to build a software within them where they keep on capturing the videos, and they are actually trying to understand, automate the or car driving mechanism, right? So obviously they need to have a mechanism where convert these videos into messages and analyze those messages. And then coming to the manufacturing, connected trucks are there, where trucks will have sensor data which is you know deployed in that, and this sensor data would be used for sending the truck locations, even the engine coolant location levels. So the advantage is that when a truck is being passed out, this information is actually being consumed centrally, and certain decisions are taken, and the truck driver can be informed that, what, there is some kind of a maintenance that you have to plan for. Your engine coolant level is much lesser, so you have to plan accordingly. So some of the use cases, especially from a prescriptive analytics point of view. And then from an oil and gas, this has been a huge and uh, potentially challenging use cases as well, where you will have oil and gas sites where it would be the internet connectivity and all would be much lesser. But at the same time, you should have periodic visits to the sites in the sea, where a lot of excavations and researches are happening, right? So the analytics related to that, uh, getting the data into data lake, and performing the analytics on top of that. Then coming to some of the IoT specific things, so you'll have engine manufacturers or cargo manufacturers, where you can actually deploy the cargoes into multiple areas. Then IoT real-time monitoring systems. You have multiple ships getting built, but you want to understand um, how the ships are actually deployed across the globe, right? Then in the insurance model, pay as you go kind of model, right? And pay as you drive as well. So typically we pay the insurance blindly. So you'll have a insurance that you have to pay for your car or your bike or vehicle. But how about the insurance also being made with based on your driver behavior, right? Driving behavior. Say for example, a good driver should pay only lesser insurance amount. A rash driver could pay more insurance amount. So those kind of analysis is being carried out with the help of the kind of drive patterns, the sensor data that is being captured. So those are some sort of a application trend that we can see. And from a retail per se, there are a lot of research companies where they try to research with respect to your, say, the viewing pattern, the digital content that you're actually trying to watch. Say for example, Netflix and the primes of the world. So they try to recommend you some of the movies or the contents based on your interest or your watch histories, right? So those are some sort of real-time analytics that is actually happening. Um, Again, retail kind of information, retail analytics that is being performed on the retail data that is getting collected across the retail industry, right? So those are some of the examples. I'll just take a pause here. I'll take some questions and then try to continue. We only a few slides left. Any questions?
Okay, it's time to go out with some queries. You can post your queries in the chat box. If you have any queries regarding the contents so far, you can post your queries in the chat box.
So I'll yeah, let me know. Interrupt me if you have any questions. I'll just
So there is one question.
okay. All right.
Any application of analytics in human resource management?
Yeah. Um, Not straight away, I would say, from a human resource management, but there can be some kind of an applications. But I can relate to some of the examples. Say, for example, um, airport analytics and the airline analytics, right? Say where in an airport, how the humans are actually um, doing their navigations. So there are certain airports which actually conduct some kind of an analytics like that, right? They actually try to understand how, say for example, you might be connected to some of the Wi-Fi's in the airports. So you actually also agree to some of the terms and conditions, and um, based on that, it is possible to understand the MAC IDs of your machine or your the IDs related to your devices, and they can understand that. So based on your movement, they can provide some kind of a uh, suggestions for some of the retails or some of the purchases of the offers, right? So these are some of the examples um, in terms of the human things, but exactly related to human resource management, there can be certain scenarios where how a workforce is actually getting optimized, how the feedback of the workforce can be leveraged for improving the experience for the customers. So customer 360 can be one of the use case in relation to that, where you actually get the different feedback from the customer, not just from the enterprises. They also try to get the information from the uh, third party sites and try to do some kind of sentiment analysis, and then try to understand bucket that particular user or a resource, and try to understand the behavior and provide some offers. So in that way, some level of HRM analytics can happen. Any other question?
Nothing, sir.
Okay. So some of the other aspects is with respect to the agriculture. This is also getting a lot of traction. Precision agriculture, right? So where they wanted to take the geospatial images, the GIS images, especially when you have drone-based images being taken up, and then try to understand the structure of the land uh, with this kind of images, and trying to predict the agricultural suitability of that particular land. So these are some of the kind of examples and the use cases that people are trying out across the globe. We have certain examples where people have tried out in a much efficient way. And forest services, right? Some of the foreign countries, they have specific services where forests are reinstated and forests are trying to build in larger areas of the country. For that, they wanted to understand how precision forestry can be done, which kind of for the trees can be planted or can be leveraged, which kind of land we can leverage. So those kind of things are also being covered as a part of the forest services. And another one is a medical research services. A lot of automations are happening in terms of the robotic surgery. So that surgery is that complex, and think about a robot itself is being doing that, right? So precision made robotic surgery has to be done. It has to be done with the help of a lot of predefined setups and analytical models. A lot of images and video analytics has to be done as a part of that. So those are a couple of examples whereby it is being leveraged from a medical research point of view. So I just wanted to cover up. Yeah, I mean, these are some of the application trends as well in terms of these things. So I think that's it from my end. Any other questions? Anything else that you want to address? We
Yes,
can.
sir. Yes,
Yeah.
sir. One more query is there. Does cloud data face jurisdiction issues? Does cloud data face jurisdiction issues?
Cloud data. Okay. So typically there are certain kind of compliance rules. Say for example, GDPR compliance. This is a compliance rule that is been primarily launched by the Europe, right? So in that, the rule is like the data shouldn't leave the Europe premise, which means that um, you know that Azure or AWS, these are the cloud public cloud vendors, but Azure will have a data center, or they call it as a region within the Europe itself. So the jurisdiction rule is that the data shouldn't leave that particular region out of Europe or out of say Netherlands. So those kind of jurisdiction rules will be there, especially on the cloud. And definitely these kind of rules are also coming in India, and also I believe US also have similar kind of rules. But that is not a problem of moving the data into cloud, because you have certain regulations which we have to follow in terms of cloud.
So one more question. Could you
Yeah.
brief on reference architecture?
Yeah. So the reference architecture is something, um, say for example, you want to build a cloud-based modern data platform, right? So what you have to do is that you have to load the data into a landing zone in cloud, probably a data lake, and then you should have some kind of a data quality check applied on top of the data. And then you should have certain kind of a transformation where your data should be massaged into a certain scenarios where your application has to consume it, right? And then this particular data has to be stored into some data marts where a specific kind of analytics will be performed for certain business scenarios. So that is where you will have specific star schema models, Snowflake schema models. So those kind of models will be coming into picture where people build the models. Above all, you should have some kind of a governance mechanism. You should have the data security, encryption, should have a proper monitoring mechanism, you should have a cataloging mechanism, should have a metadata management mechanism. All of those things will be coming as a part of the entire end-to-end data lifecycle chain. So altogether, you can say these are the key components of a cloud-based architecture or a data lake kind of architecture. And when it comes to cloud, every cloud vendor, say AWS, Azure, everybody has got their own technology stack. Only thing is that they should have some of the tools in Azure. It can be Azure Data Factory and Data Catalog, whereas in AWS it can be AWS Glue. But it doesn't Glue in Google. It can be Cloud PubSub or Cloud Data Catalog, Bigtable, etc. So different kind of storages, different kinds of technologies are there. Every cloud has got tailor-made fitment of reference architecture. What we have to follow is that according to each of the cloud, say for example, we might be looking for only Google Cloud implementation, then we should go for a Google Cloud-based reference architecture. Only thing is, this technologies, these services are primarily the PaaS or SaaS-based services offered by the cloud, and they will have a lot of iterations happening, and this architecture may get changed over the time, right? So you should always take a look at the latest architecture that is available on the cloud. Hope that answers the question.
It looks like we have covered all the questions.
Yeah.
So I'm taking this opportunity to express our sincere gratitude to Mr. Thomas Sebastian. It was an amazing and fruitful session, which covered almost all the dimensions of data, its storage and analysis. I'm sure that all the participants must have got an awareness of the concept of data in the viewpoint of a customer as well as a system which provides a service, no matter whatever the service is. And it was well-packed presentation within the constraints of time. Thank you, sir. Thank you so much.
Thank you. Thanks a lot.
And I thank all the participants for joining us today. And we will see you tomorrow at sharp 11 a.m. So we are winding up for today. Thank you.